Let's discuss important topic called fluid kinematics. Okay, so before going more into what are the parameters which are used to measure the fluid kinematics of the fluid particles, let's first discuss what is Lagrangian versus Eulerian approach. Okay, these are basically the two approaches which are commonly used in mechanics. So let's see what is Lagrangian. So Lagrangian is basically more like a system approach, so where you follow the path of individual objects or individual fluid particles. So it's basically something like a free body approach. You take a body or you take a fluid particle and you just track its path or track the path of individual objects like fluid particles. So going by this definition, you can say that it is very difficult to apply this because describing fluid in Lagrangian is more difficult. It's more difficult as you have so many particles and the interaction between each, interaction among the particles is also complicated. Okay, so we don't adopt this because this is a particle approach. The other approach is Eulerian approach, which is basically we do is a finite volume, typically called as the control volume, is selected, is defined. First you define that control volume and through which your fluid enters, through which the fluid enters and exit out. So your domain of analysis is basically that control volume. So we don't need to keep track. One advantage is that we need not keep in track the position and velocity of individual fluid particles which are of fixed identity. And the Lagrangian was doing that. You take a particle, name it, and then you track the motion of it. But Eulerian, you don't do that. Instead what you do is you define a fixed variables which are a function of space and time. That means it's something like this. You have a fluid particles, you're just tracking the motion of it. You're going after it. That is Lagrangian approach. The Eulerian approach is you're standing at one place. Okay, you're standing at one place, and if whatever the fluid particles that pass through that place, you measure the velocity. Okay, so you have a probe kept at a point and then you measure the velocity acceleration at that point. So basically here you define space variables. Define space variables means variables which are function of space, like your velocity, acceleration and stuff like that, and your pressure field. So what you get is you define field variables which are functions of space and time. That's what you do in Eulerian. So your pressure field will be p x y z comma t, and your velocity at a point will be x y z t. So then you can keep the probe at any other place, you measure the velocity. So the field variables are defined at any location in control volume and at any instant in time. That is your Eulerian approach. So it's something like this: person standing at a river and measuring the properties. Let's say you are standing and measuring. So one advantage is all your experiments data will be in the form of your Eulerian approach, because experiments when you do, they are all more suited to Eulerian approach, because you have a probe at one point and you measure the parameters at that point. Okay, you measure the parameters at that point. So experiments approach is more suited to this.